Hello, my name is Richard Santos, and I'll be presenting here a presentation based on cellular and mobile network technologies. Per the instructions in the assignment, the CEO of the hospital that we are putting together in terms of the network infrastructure has asked me to explore more possibilities of replacing the current wireless 802.11x phones with a full cellular system. And so we'll just go ahead and jump into it. So first of all, we'll kind of discuss some information regarding the security program. It is worth mentioning that just transitioning from 802.11x wireless phones to a cellular system, it could significantly enhance communication reliability, the security, and overall coverage within the hospital. By exploring this in more detail, those changes and improvements, which focusing on the programs in cellular generations, smartphone operating systems, and just other required adjustments could really benefit everybody here in the facility. But start things out, we have encryption, authentication, access control, managing devices, and monitoring and logging activity. When it comes to encryption, just ensuring that all voice and data communications are encrypted using strong protocols, the standard ones, and a good example one is advanced encryption standard for end-to-end encryption and voice calls. The authentication aspect, it just works to implement multi-factor authentication for then accessing network and hospital apps, just to obviously get patient records and whatnot in a secure manner. And of course, access control, always important. It's just regulating who can access sensitive data, and then just using a role-based access control in general. When it comes to device management, uh, there's different aspects that are able to be integrated, but one of the most profound ones is mobile device management, which many solutions can be in place just to enforce additional security and just manage the configuration of the device and even remotely wipe if necessary. And lastly, monitoring and logging activity, just the continuous monitoring of like network activity, and then maintaining those logs for future reference is just going to be very vital. Next, we have just core architectures. I broke this up into two parts, and first we'll just kind of discuss some of the different generations of technologies. Uh, Ranging back from 2G, this uses something called time division multiple access and frequency division of multiple access, and it's just mainly used for voice and basic data services. The security is relatively basic with some encryption standards in place. But then, of course, moving on to the two different types of 3G, which just provides better data rates in comparison to 2G with simultaneous voice and data options. Um, it also uses different methods of coding for just spreading the signal overall, just and of course enhancing security features and the capabilities. And lastly, which is more in line with today's technology, 4G, and obviously even moving into 5G, but it just offers more of a high-speed transfer in data, supports advanced apps like video chatting, and then uses a different frequency division multiple access just for uh, essentially enhancing the security with robust encryption and just the overall integrity. And just moving on to the next slide here for the second part of that core architecture, just some of the differences that are kind of involved with the architecture. Circuit switch versus packet switched. Uh, they're primarily used for voice technology. LTE 4G is, it's fully packet switched, which then provides a better, efficient, and scalability option in the future. The frequency bands and the spectrums, each generation range from 2G to 4G. They use different bands when it comes to frequencies, which affects that coverage, data rate, and the overall capacity, which then brings us into latency and throughput. Each generation it does improve upon it with the latency and throughput, with of course LTE providing the best performance. Next, we're going to talk about end-to-end packet delivery, which it could arguably it is within the 802.11.x standard, but just with implementing more of a cellular aspect within the hospital, I think it's important to understand these five different aspects. So when it comes to initiation, the data packet it's initiated from a mobile device, whether it's a voice call or data request, which then kind of moves into routing. That packet then routes through the base station or nodes to the core network, which would then be the LTE or 4G. Then, of course, we have the core network. They will pass through that packet that is to various components within the gateway. Um, and of course, that's where we've kind of discussed it in previous assignments, but that quality of service policy and the security checks that or audits that will take place, it'll pass through that. And then, of course, moving on to the internet or a private network, it will be delivered. It being the packet um, to like either the server within the hospital or an external website, for example. And then, of course, the handoffs. When the user moves, the packet's routing path it can change, and that of course involves handoffs between the different base stations, and that ensures seamless connectivity. LTE, of course, 4G, it supports that handover with a minimal packet loss and latency, which I just think is important for implementing that level of technology. And then, of course, the embedded smartphone operating systems. Obviously, the two to choose between is iOS, which is Apple iPhones, and then Android, which are simply Android devices. Really, the discussion of that, 2G, 3G, 4G, and even 5G kind of come back into place. 2G kind of being the lowest with basic voice and SMS text message services with limited data. When we move up to 3G, it's a more of enhanced voice, SMS, and moderate data speeds. And then, of course, 4G has the higher speed data. Voice over instead of voice over IP, it's called voice over LTE, and that's just to support higher definition video calls, faster internet access. And then lastly, something that's obviously becoming a little more prominent in our lives, just 5G, which is considered ultra high speed data, very low latency, has much support for Internet of Things. When you think of connecting different devices that use the internet or that are kind of Wi-Fi based, that concept, and then it just overall enhances the mobile broadband usage. With that being said, iOS is known for being very secure, easy to use from the end user perspective, and has good integration with healthcare apps. It is ideal for hospital environments, just due to the robust security controls and then the closed off ecosystem that a hospital would have. The Android, of course, it does offer flexibility. It is a little cheaper. A wider range of devices, can be implemented. So there's definitely a larger catalog to choose from. And it does have strong security features when properly managed. It is suitable for diverse cases, and just the customization aspect is really the biggest thing with Android. Next, just to discuss some of the changes to the network infrastructure, different mobile protocols, the logical channels, and the encryption standards. In terms of mobile protocols, it is important to utilize like a standard cellular protocol such as 4G. That way we can implement voice over LTE and just ensuring backwards compatibility with 3G networks, more of like a legacy compatibility, if you will. Next, logical channels. Just having that proper configuration of the logical channels to control traffic, and then of course optimizing the performance of the network. And lastly, just the different encryption standards, so that way we can enforce those strong standards, uh, mainly just to secure the data, the transmission of this data, and just ensuring all communications have that end-to-end encryption that was mentioned earlier. And one of the last things we'll discuss is just the mobile unique identifiers. So of course, you have mobile unique identifiers such as IMEI and IMSI, and that's mainly for just device identification and management. It helps to employ these identifiers to track and secure devices. But then we also have location-based services. This, of course, will have more leverage on GPS technology and using network-based location services to track the device within the hospital, ensuring staff can be located quickly in certain emergencies. And that does bring us to the end of the presentation. Now here are the references that were utilized here to talk to these main points. And this is the end slide, so thank you very much.